back, 8th graders. It's Mrs. Thompson. We're going to start back into 6.3 again. This time we're going to do example 2. Remember, in example 1, we found the degree of a monomial. We learned what that was and found the degree. I taught you how to do that. Today, example 2, we're going to find the degree of any polynomial. Now, you're probably wondering, what in the world is a polynomial? It's a very strange word. You're going to see at the very beginning of it, poly, that is just Latin or Greek for many. So we're talking about a problem, an expression that has many terms, more than one. A polynomial can actually have just one term or more than one term. That's what a polynomial is, excuse me. So that's what I put as your definition. It could be a monomial, and so you could call it in general a polynomial. That's fine. Or it's a sum or difference of monomials. So you've got a series, one or more monomials that you're adding or subtracting together, and we can call them collectively, the whole thing, a polynomial. Okay? So just to make it real simple, it's very much one or more terms. That's what a polynomial is. It can be one term or it can be more than one term. That's a polynomial. Now, to find the degree of a polynomial, it's a little bit different, the degree. What you do is you find the degree of each monomial. You do it individually. Focus on each individual monomial, find the degree. And whichever one is the greatest number, that's the degree of the entire polynomial. Let me show you what I mean by that. I think it would be a little easier to show you. Okay? So let's start here with letter A, 4x. Let's just focus on 4x. The whole polynomial, this whole thing right here, the whole thing is a polynomial. Okay? This particular polynomial has two monomials. Here's the first one. Here's the second one. See how they're separated by a subtraction sign. Yep, that means that's two separate terms. And so you have two monomials put together here. All right, so let's just focus on this first one, 4x. Okay, how do you find the degree of a monomial? Just a single term. All right, look at the variable. What's the exponent on that x? You're right, it's a 1. Now go back and let's do the 18x to the 5th. Focus on the variable. What's the exponent on the variable? Right, it's a 5. Now which one of those numbers is bigger? You're right, 5 is. So the degree of this whole entire polynomial is 5. Okay, did you see what I did there? I found each individual monomial's degree. And then I circled the one that was the bigger of the two. And that's the degree of the entire polynomial. All right, let's move over here to B. Do you see 3 terms here? I do too. They're separated by addition signs. So that's how I know they're 3 separate terms. So let's first focus on this first monomial. It's 0.5 x squared y. So remember, to find the degree, focus in on the variables, x squared y. Add up those two exponents. And remember, that's a 3, because 2 on the x and 1 on the y, those exponents add up to be 3. Okay, let's go to the next one. We've got our second term, 0.25 xy. X has an understood 1 exponent, and y also has an understood 1. Add those up. 1 plus 1 is 2. And that's the degree of that monomial. And let's go to the third one. Third one doesn't have any variables on it. That's a constant number, and all constant numbers have a degree of 0. So let's look at our choices. 3, 2, 0. Which one's the bigger number, the biggest number in that set of 3? You're right. So 3 is the degree of that entire polynomial. That's what we would say. It's the entire polynomial has a degree of 3. Okay, let's look at letter C. Do you see 1, 2, 3, 4 terms here separated by either an addition sign or a subtraction sign? I do too. So we have a 4-term polynomial. Let's look at 6x squared. Let's start right here. X has a 4 exponent, and that's the degree of that individual monomial. Now let's go next door to 9x squared. X has a 2 exponent. That's the degree of that monomial. Let's go over here to 4x. X has an understood 1 exponent, and that's the degree of that monomial. And then 3 is a constant number, and all constant numbers have a degree of 0. So you have 4 numbers to choose from. Which of those 4 numbers is the biggest? You're right, 4. So that's the degree of the entire polynomial. Let's look at letter D, 5x minus 6. Okay, hey, I see 2 terms here in this polynomial. This is a 2-term polynomial. So 5x, the x has an understood 1 exponent, so that's the degree of the first one. And 6, with it not having any variables, it's a constant. All constant numbers have a degree of 0. So of those 2 numbers, 1 or 0, which one's bigger? That's right. And so 1 is the degree of that entire polynomial. It's always the biggest number. Okay? All right, let's look at letter E, our last one here. So we've got 1, 2, 3, 4 terms in our polynomial. So let's figure out the degree of each of these. All right, so let's start here. 3 plus 2, yep, that's 5. 2 plus 3, yep, that's still 5. This one's a 4, and that's a 0. So of the numbers that are listed here, which one's bigger? Well, this is a tie right here. So that would mean that the degree of this particular polynomial is 5. Okay, so hopefully that was not confusing to you at all, and that you understand the difference between finding the degree of a monomial versus finding the degree of a polynomial that has more than 1 term in it. Okay? Hey, let's have another bonus, okay? Let's do another bonus. Find somewhere on your paper, don't jam it in somewhere, get some clean spot here. Because I want you to know those exponent rules so much, let's try those again. What are the 3 exponent rules we learned in 6.2? Write those down on your notes or on a separate sheet of paper and show me tomorrow. Okay, if we've already done that, just disregard. Thanks a lot for listening.